Just as we applied transformations to functions and relations, we can now apply transformations to matrices. So recalling that we have three types of transformations: translation, reflection, and dilation. So translation is where each point in the plane is moved either horizontally or vertically. So take, for instance, this triangle. We can move it horizontally and vertically at the same time so that it moves up and across to the right to this position here. Oops. So reflection. Reflection is just the mirror image of each point, and it's found about a line of reflection. So if we take the line of reflection here to be the x-axis and we take some triangle on this side of the x-axis, we can find its mirror image underneath the x-axis here where this red triangle is. Dilation changes the size of a figure. So the figure is either reduced or enlarged. We talked about it previously being either widened or made narrower. So we talked about things like this parabola. So if we take the blue parabola, we can multiply it by a dilation factor so that it becomes narrower, or we can multiply it by a different dilation factor that might make it become wider. So before we do this using matrices, we need a few pieces of notation. So a point on a Cartesian plane is usually denoted by xy. And matrix representation of this point looks like this: x, y, written as a matrix. So a point that's undergone some sort of transformation is called x dashed, y dashed in matrix form. So imagine the figure of the blue triangle below is to be translated to the position of the red triangle. So I've got some triangle here, ABC, and it's going to be moved up here so that we have a triangle A dashed, B dashed, C dashed. So if we just have a look at the top corner, so the point A, we see that it's gone 6 up. 1, 2, 3, 4, 5, 6, and it's gone 4 to the left. 1, 2, 3, 4 to the left. So we can represent the translation in the following way. So we want to know where the new point x dashed y dashed is. And what's happened, if we've got some point xy, so let's just concern ourselves with one point because it's the same for any of these points. And it's been moved 4 to the left, so we have to put that as -4. And then it's been moved 6 up. So this here is what we call the image point. It's the point that's been shifted. This is the original point, or called the pre-image point. And we call this matrix here the translation matrix. So then remember that we've got a negative there. Because we moved left. So if we moved right, we'd have +4. And similarly, if we moved down, then instead of a +6 here, we would have had a -6. So the coordinates of corner A, if we have a look back on our diagram, the coordinates of corner A are 1, minus 1. So under that translation, the new coordinates become our new coordinates, x dash, y dashed, become our original coordinates, x, y, which are 1 minus 1, plus the translation matrix. Remember, addition of matrices, we add elements in the same position, so we add the 1 to the minus 4, so it gives us minus 3, and we add the minus 1 to the 6, which gives us 5. So our new coordinate, x dashed, y dashed, for a, so that's a dashed, is minus 3, 5. And if we check, we can see that it is minus 3, 5. Sorry, I just rewrote that to make it clearer. So put this piece in your summary book. So an image point can be found by adding a translation matrix to the original point. So we can actually represent more than one piece of information in a matrix. So if we take all the coordinates of the corners of our triangle, so we've got 1 minus 1, 1 minus 4, 3 and minus 4. So that's just the coordinates of that blue triangle. So if we put them all into a matrix, we can write them in like this. 1 and minus 1, 1 and minus 4, 3 and minus 4. So as we're going to apply the same translation to each point. So we can write the translation matrix like this. We're going to move minus 4 to the left and 6 down for each point. So thus our new set of coordinates will just be our original set plus our translation matrix. Minus 4 plus 1 is minus 3. Minus 4 plus 1 is minus 3. 3 minus 4 is minus 1. Minus 1 plus 6 is 5. 2 and 2. So point A dashed is, as we've worked out before, minus 3, 5. Sorry, I forgot which order I did them in. B dashed, then is minus 3, 2. And C dashed is minus 1, 2. We can check them on our picture. Minus 3, 2 and minus 1, 2. So have a go at exercise 7.6, questions 1, 3, 9 and 10. Okay, so we can also translate lines and curves. So if we take this parabola here, the blue parabola, which is just the base parabola y equals x squared, and we're going to translate it 3 positions to the right. So the red line is y equals x squared, sorry, that's the blue line is y equals x squared. So we want to find the equation of the new image, the red parabola. So the first thing we need to do is write down the matrix transformation. So a new point on the parabola is given by an old point on the parabola, or an image point is given by a pre-image point. We're going 3 across to the right. We're not going up or down, so we leave that as 0. Then what we're going to do is write what we call the image equations for both coordinates. So the way we do that is we say our image of x is given by our old x plus 3. Our image of y is just given by our old y plus 0, which is of course just y. Our next step, so we rearrange both image equations to make y and x the subject. So in other words, we have, if we subtract 3 from both sides of that first image equation, we have x equals x dashed minus 3, and of course y is just equal to y dashed. So once we've got these two rearranged image equations, we just substitute So substituting straight into the original equation for the parabola, our original equation was just y equals x squared, y becomes y dashed, and x becomes x dashed minus 3 all squared. So our image equation, the equation of the red parabola, is just y equals x minus 3 all squared. So I have a go now at questions 5, 7, 13 and 14 from exercise 7.6. There are some more examples on 381 for help if you need. So if instead of being asked for the image equation, if we're just asked to find the translation matrix, so an example could be that to find the translation matrix that maps the parabola y equals x squared to the parabola y equals x plus 3 squared minus 4. So you should remember that if we have some parabola in this form, called the turning point form, that the h moves the parabola left or right, and that the k moves the parabola up or down. So in our case, we have plus 3, which means it's me moving 3 to the left. I've got minus 4, so it's 4 down. So the parabola is shifted 3 to the left and 4 down, so the translation matrix will be equal to minus 3 because it's going to the left, and minus 4 because it's going down. So after doing that, you should just be able to finish off that exercise with question 16.